Good morning, students. Myself, Jyoti Saroj, your science teacher. Welcome to 9th standard student. Today we are going to learn a new chapter on acid, bases and salt. Now before we start with this new chapter, I want everybody to open page number 58 of your science textbook and move on to next line. Thank you. Students, in this chapter you are going to deal with Arrhenius theory of acids and bases. This theory was given by the scientist Arrhenius, means the definition of acids and bases. Next you are going to deal with concentration of an acids or bases. Concentration means the strong of acid and base, means power of an acid or a base. Next is pH of a solution. As you know, pH stands for strength of hydrogen ion in a substance. Earlier we have studied about pH scale that ranges from 0 to 14. That means if the solution has pH less than 7, it is acidic in nature, and if the solution is having more than 7, that means the solution is basic in nature, or you can say it alkalis in nature. Next we will see pH of an acid and a base, and the last we are going to study about salt. Now proceed to next. Okay students, let us see what are acids and bases. We have already learned earlier that some foodstuffs are sour to taste. For example, lemon, grapes, oranges are sour to taste, while others are bitter and slippery or soapy to touch. When these substances studied scientifically, it is found that they contain acidic and basic substances respectively. For an example, if the substance is sour to taste, that means it's acidic in nature. For an example, lemon, grapes, oranges, these are acidic substances, natural acidic substances. Some are soapy to touch. For an example, soap. You can say it washing soda, baking soda, these all are bases. It is found that they contain acidic and basic. We have also learned an easy and safe method of using an indicator like litmus paper to identify acids and base. Now, student, you know what is litmus paper? It is obtained from one kind of a plant. Litmus paper, whenever it is dipped in a acidic solution, if a blue litmus paper dipped in a acidic solution, it will turn red, and if it is any red litmus paper dipped in base, it will turn blue. That means red color indicate acidic and blue color indicate base. Okay student, let us move further. As you can see in your textbook, one column is there. Fill in the part of the following column. In that column, you are having name of the compound, molecular formula, basic radical, acidic radical, and a type of a compound. One is done for you. For an example, HCl. Molecular formula is HCl and the name of the compound will be hydrochloric acid. Now, basic radical is H plus and acidic radical is Cl minus. Compound is acidic. As it is already mentioned, it is acid. Now, next is HNO3. HNO3 is nitric acid. Again, the basic radical will be H plus. Acidic radical will be remaining NO3 minus. Again, it's acidic. Rest are done for you. Please see it and write down in your textbook with pencil. Now student, now how you will come to know whether the substance is acidic or basic? For an example, if the solution is having H plus ion, as you can see HCl, HNO3, HBr, H2SO4, these four compounds will have H plus as a basic radical. Are you getting? H plus as a basic radical, that means it is acidic in nature. Now next you see NaOH, KOH, CaOH, NH4OH. These compound will be having OH minus. Are you getting, student? OH minus, that means hydroxide in their compound. It is a base. See, acid will have H plus ion and the base will have OH minus. Now next is CaNO3, K2SO4, CaCl2, NH4,2SO4. Now these compound is neither having H plus nor having OH minus ion. That means it is neither acidic nor basic. So it will be salt. Are you getting, student? The compound which have H plus, H in their compound, in their molecular formula, it is acidic. If the compound is having OH minus, OH in their molecular formula, that means it's a base. And if the compound is not having H and neither having OH, that means the compound is salt. Students, in the earlier slide you have learned about acid, bases and salt. Now you have completed your part B as well. It will be clear that there are three types of ionic compounds, and these are acid, bases and salt. As you know, acid compound will be having H plus, bases will be having OH, and salt will neither be having H nor it will be having OH. So on the basis of this, can you classify the following examples as acid, bases or salt? Complete this in your notebook. Okay student, our next topic is ionic compounds. Now let us see what is ionic compound. As you can see in the image, there is one cation and an anion is there. There is a bond between cation and anion. Now cation is that which carries a positive charge. Positive means cation. And anions are those which carries negative charge. Negative means anions. Okay. Now we are having metals and non-metals. So metals are always positive in charge and non-metals are always negative in charge when there is a formation of a substance. For an example, as you can see in the image, sodium is there which is Na and fluorine is there. Sodium which is metal and fluorine is non-metal. So sodium is having one extra electron and fluorine needs one electron. So metal is always positive in charge. It will give one electron to the fluorine, and fluorine will accept one electron and complete its octet. So there is a sharing. Why there is a sharing between them? Because there is an oppositely charge present between them. Understanding? Oppositely charge present between them. So there is a sharing. They share a strong bond because they are opposite in charges. So this is called ionic compounds. When there is a sharing between two oppositely charged ions, they are called ionic compounds. Now proceed to next slide. So student, more in detail which is present in your page number 59. See, ionic compound, there is a formation of compound between sodium and chlorine which forms a sodium chloride. As you can see in the image 5.1, there is a sodium which has electronic configuration 281. That means one extra electron is there. There is a formation, bond formation between sodium and chlorine. As you can see, chlorine is having 287. Chlorine is non-metal and it want one electron to complete its octet, or you can say shell. Okay, so sodium will give one electron to chlorine to complete its octet. Even chlorine will also get complete, and sodium will also get complete octet. So there's a sharing. As you can see, sodium gives 1 electron to chlorine. Now both the elements are completely filled. Okay, so sodium chloride is formed with an ionic bond, as you can see in your textbook. Okay student, today we will stop here. In next presentation we will see more about ionic compounds. For an example, dissociation of ionic compounds, and further in detail. Thank you.